Friends, today I am going to explain large and small sample tests. So, large sample when n is greater than or equal to 30, small sample when n is less than 30, and test of significance for single mean. To learn this, both the small and the large, we have to habituate this terminology. That is, sample mean is denoted by x bar, sample standard deviation is denoted by s, population mean is denoted by mu, sample size is denoted by n. Now, the question is, the height of college students in a city are normally distributed with standard deviation 6 centimeters. A sample of 100 students has mean height 158 centimeters. Test the hypothesis that the mean height of college students in the college is 160 centimeters. First, you write the given data. Now, according to the data, sample mean is given 158, which is denoted by x bar, and population mean is given 160, and standard deviation is given sigma is 6, and n is equal to 100, which is called sample size. Now, first of all, you write null hypothesis. Null hypothesis is denoted by h naught, and which is mu is equal to 160. Now, complement of alternative hypothesis. Alternate hypothesis is denoted by H1. So, alternate hypothesis is complement of null hypothesis, which is mu not equal to 160. Here we have two tests, two tile test, one tile test. Okay, here if it is not specified anything, generally we are taking a two tile. Okay, if it is specified, then we can take one tile. It's depending on the question, right? If it is not specified, you can take two tile test, right? Next, third step is level of significance. If it is not specified any significance level, we generally take 5% or 1%. Okay, now here I am taking 5%. 5% in the sense 0.05, which is denoted by alpha. Next, table value. Table value at 5% level of significance for a two-tailed test is 1.96. You have to remember. And test statistic for large sample for single mean is z is equal to x bar minus mu by sigma by root n. Now calculate this. Here x bar is 158 minus mu is 160 by sigma is 60 and n is 100. Now take modulus and calculate, and finally we have the value is 3.33, and here calculated value is 3.33 and tabular value is 1.96. In this, we observed that calculated value of z is greater than the table value of z at 5% level of significance. So, we reject the null hypothesis H naught. If calculated value is less than table value, then we accept. Yes, and we go for a small sample test. That is, okay, it is also called t test. Small sample is applied for n less than 30. Okay, and remaining process is same, but here additional point is degree of freedom. Okay, right. Here a random sample of 6 steel beam has a mean compressive strength of 58,392 with a standard deviation of 648. Use this information at the level of significance alpha 0.05 to test whether the true average compressive strength of the steel from which this sample came is 58,000. Okay. Now, given data, sample size is given 6. Okay. Because where it is here 6 steel beams, that is n is 6, and sample mean is 58,392, and sample standard deviation is 648, and population mean is 58,000. Okay, now write step 1 null hypothesis, which is 58,000, and alternate hypothesis is denoted by h1, mu not equal to 58,000. This is a two tile test because it is not specified. So, level of significance alpha is equal to 0.05. In the question given 0.05 level. Okay. Next, degree of freedom is n minus 1. Here n is what? Here n is 6. So, 6 minus 1, 5. And the table value is 2.57 for 5-degree freedom. Okay, this is we can see in a t distribution table. Okay, next, test statistic t is equal to x bar minus mu by s by root n. So this is also called t test. For a small sample we can use t test. So its test statistics is x bar minus mu by s by root n. Okay, now substitute the above values in this formula. X bar is sample mean is what, 58,392 minus population mean is 58,000 by 648, that is sample mean, sample standard deviation, by root n, n is 6. And now simplify this, we can get the final answer is 1.48. And observe that 1.48 is less than table value. According to the definition, when calculated value is less than table value, then we accept. Otherwise, we reject null hypothesis. So here calculated value is less than table value. So we reject, calculated value is less than table value. So we accept the null hypothesis H naught. Okay. When the calculated value is less than table value, we accept null hypothesis H naught. When calculated value is greater than table value, we reject null hypothesis H naught. Okay. So both procedures are same. In small sample, additional part is degree of freedom. Okay. Again, we will discuss another problem. Second one is, it is claimed that a random sample of 49 tires has a mean life of 15,200 kilometers. This sample was drawn from a population whose mean is 15,150 kilometers and a standard deviation is 1200 kilometers. Test the significance at 0.05 level and also find 95% confidence limits. Okay, now given data, here the sample size is n, which is 49, and sample mean is 15,200, population mean is 15,150, and population standard deviation is 1200. Okay, right. Now null hypothesis H naught mu is equal to 15,150. Alternate hypothesis H1 is equal to mu not equal to 15,150. Level of significance 0.05. Okay. Table value 1.96. Test statistics z is equal to x bar minus mu by sigma by root n. You is substitute the above values in this formula. We can get 0.29. Okay, 0.29 is certainly less than 1.96. So we accept null hypothesis H naught. Okay, that's enough. And also here we have to find 95% confidence limits. If an examiner asks to find 95% confidence limits, we have to find. Otherwise, no need. But here examiner asks to find 95% confidence limit. 95% confidence interval is x bar minus z alpha by 2 into sigma by root n, comma x bar plus z alpha by 2 into sigma by root n. Okay. Here we know that sample mean. What is sample mean here? 15,200. Put here minus z alpha by 2 is 1.96 into sigma is 1200 by n is 49. So root 49 comma 15,200 plus 1.96 into 1200 by root 49. And we simplify 4 14,864, 15,536. So these are the confidence limits. So confidence limits are 14,864 and 15,536. Okay, and here small sample test. But in this question we have a data. Using this data we can check. Okay, here the question is random blend sample for test of fasting sugar for 10 days gave the following data in mg per dl: 70, 120, 110, 101, 88, 83, 95, 98, 107 and 100. Okay, do these data support the assumption of a population mean of 100 mg per dl? Find a reasonable range in which most of the mean fasting sugar test of the 10 boys lies. Okay. So, given how many sample points? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, sample size is n. N is 10. And to find test statistics, we require x bar mu s. Okay. First of all, you have to find x bar. X bar is what? Sigma x by n. So 70 plus 120 plus 110 plus 101 plus so on plus 100 all by sample size, which is 10. 972 by 10, which is equal to 97.2. This is a mean. Okay. Now, okay, given x is 70, 120, and now x minus x bar. Already we found that x bar is what? 97.2. Simply 70 minus 97.2, which is minus 27.2. 120 minus 97.2, 22.8. We can find similarly. And also calculate x minus x bar square. Minus 27.2 whole square, we can get 739.84. 22.8 whole square, 519.84. So finally, we find sigma x minus x bar square is 1833.60. So s square is sigma x minus x bar whole square by n minus 1. Here sigma x minus x bar square whole sigma x minus x bar whole square is 1833.60 by 10 minus 1, which is 203.74. So s square is equal to 203.74, s is equal to root 203.74. Okay. After calculation, we write the steps. Null hypothesis, mu is equal to 100, because it is given mu is equal to 100. Now take alternative hypothesis, mu not equal to 100, which is two-tailed test. Level of significance, we are taking alpha is equal to 0.05. Degree of freedom, n minus 1. Here n is 10, 10 minus 1 is 9. According to the table, we have 2.262 for 9-degree freedom. Okay. Now test statistic is t is equal to x bar minus mu by s by root n. Here x bar is 97.2 minus mu is 100 by s is root 203.74, and here n is 10, root 10. After simplification, we can get 0.6203. And again compare with the table value. So this calculated value is less than table value at 9-degree freedom. So we accept null hypothesis H naught. And also we want to find confidence interval. So here confidence interval for population mean mu is x bar minus t alpha by 2 into s by root n, comma x bar plus t alpha by 2 into s by root n. This s by root n is called a standard error. Okay. X bar is 97.2 minus table value for 9-degree freedom 2.262 into s. S is for what? Root 203.74. Okay, root 203.74 is simplified as 14.27 by root 10. 97.2 minus 2.262 into 14.27 by root 10. After simplification, we have 87, 107.4. Therefore, our population mean lies in this range. 100 lies in between 87 and 107.4. Okay, this is called 95% confidence level. Okay, so 95% confidence level is 87, open interval 87 comma 107.4. This is called 95% confidence interval. Okay, thank you very much, and we will discuss next test in next video. Thank you.